And welcome back to the Armchair Astronomer. My name is Hugh Mortimer and I'll be your guide to everything to do with space. Now today I want to talk about a scientific instrument known as the radiometer. And I'll be referring to an instrument that I'm personally connected to because I've been working on it for several years, the Sea and Land Surface Temperature Radiometer. Now you'll realise that space scientists aren't particularly good at naming things, and this is a perfect example of this because the Sea and Land Surface Temperature Radiometer, also known as SLSTR, is an instrument that is flying on the European Space Agency's satellite Sentinel-3. And while it produces images in the same way a camera will produce images, it's fundamentally different. A radiometer is an instrument where it collects the photons of light and it detects them onto a detector, but then it converts those photons into a brightness, scientifically known as the radiance of light. And in the case of SLSTR, it's measuring in 9 different wavelengths, or 9 different colours. And it records those wavelengths from the visible all the way through to the infrared. Now, only 2 of those wavelengths of light, or channels, are measured in what we would know as the visible, that we are sensitive to with our own eyes. The rest, the 7 other channels, is measuring in the infrared, in wavelengths that we are not sensitive to. But in doing so, it means that we can measure different aspects of the planet as the instrument flies overhead. From the atmosphere, we can measure the clouds, and on the ground, we can measure the vegetation. But more importantly, for SLSTR, it can measure the temperature of the land and the sea. And because it's in space, orbiting at 7 kilometers every second, it can do so not just on every day, but it can do so for weeks, months, and years at a time. And that's incredibly important to enable us to understand the impact that humans are having on the planet.